Hi everybody, and welcome back to Math 141. We are online. I hope you're all doing well and staying healthy. This is our new delivery system. I'm down in the basement office in our house, and my wife and I have set up this whiteboard. She's going to teach some of her art classes from there. And I have my son Ethan, who is an audiovisual expert. He's a senior in college. He's running the camera and the sound back there. And we will basically teach classes just like, and take classes just like we have in the classroom building on the CCA campus. Now, if you've checked up the announcements, checked on the announcements on the D2L site, you read my my information there. We can go through the lectures here, go through the classes here, and then I'll stop after a while, just like we did in the classroom, and I'll say, okay, now you work out these problems. When you work out the problems, at that point you stop the video and work out the problems. As you work out the problems, if you have any questions, just email me right away, and I'll be checking email, off and on for the rest of the semester every day. So you can ask any questions there, and I can answer them so that you're clear on what's going on as we proceed through the material. So without further ado, let's get started on section 3.1. And by the way, let me mention about our last homework assignment. You had homework problems in the toolbox for chapter 3. If you have any questions on those homework problems, email the question to me and I can email back a solution and an explanation to you, and that's how we can go over homework for today. But for right now, we'll start in our textbooks on page 168, section 3.1, quadratic functions and parabolas. Now the text starts off with an explanation here, which I have on my small portable whiteboard, revenue model. And it explains that for a given company, there is this function r of x equals negative 0.1 x squared plus 600x. And that is a quadratic function. It's a quadratic function because it is in that form. This is a polynomial of degree 2, so we call that a quadratic polynomial. And we have a function y, and if you want, we can also name the function f, and we can say y equals f, which equals ax squared plus bx plus c. So in this case, the function is called r, and r of x equals this. So playing the role of a, I have negative 0.1. Playing the role of b, I have 600. And playing the role of c, 0. That's why you don't see a constant term. So I put this, well, let me just explain what the rest of this diagram is here. The graph of a quadratic function always has this shape. And this is right in your textbook. That shape is a parabola. Now in this case, we say the parabola opens downward. Okay? As shown on the board here, the top of the parabola is called your vertex. And a parabola is symmetrical. That means it has an axis of symmetry. If we spin the parabola around the axis of symmetry, it lands on itself. Okay, so this is a more careful drawing. And of course, this is the graph that's in your book. So, what this shows, as we mentioned last week, a couple weeks ago, not every real-life problem can be modeled with a linear function, we need to look at other functions, and that's what we're doing here in Chapter 3. This is a case where someone doing research at this company has determined that this quadratic function actually models their revenue. So we'll get back to this a little later. I'll save my portable board there. And for right now, let's learn a little bit about parabolas in general. Well, here's the simplest possible parabola. Or equivalently, simplest possible quadratic function. Playing the role of A is 1, the invisible 1. Playing the role of B, 0. Playing the role of C, 0. This is a nice simple function. It'll be easy to graph. If we plot a few points, I'll pick some simple values for x. 0, 1, 2, -1, -2. Numbers that we commonly choose. They're easy to work with. If I calculate y, well, x squared when x is 0 gives me 0 for y. 1 squared gives me 1. 2 squared gives me 4. -1 gives me 1. -2 gives me 4. Notice the pattern. Because we're squaring the x values, doesn't matter if we have the positive or the negative version of the number, we're going to get the same y value. Same thing happens for 2 and -2. They both yield positive 4 as the corresponding y value. Let's plot these points, and I just want to make a little divider line there. I have to work small now because I have a small whiteboard, so things will be tight. I'll just put a simple XY coordinate system up on the board, and if I mark that as 1, 2, -1, -2, and then mark off some y values, let me plot these points. 0, 0, the origin, is on our graph. 1, 1, -1, 1, then 2, 4, -2, 4. Let's connect the dots. You see something curving up like that. There's your parabola. It's not my most accurate drawing of a parabola. Remember, it's supposed to be completely symmetrical. If you don't believe it's going to keep curving up steeper and steeper, by all means go ahead, put 3 in and you'll get 9. Put -3 in, you'll get 9 again. And you can plot those points. That'd be way up here. Okay, so that's our simplest quadratic function, our simplest parabola. Let's notice a couple things about it. From x equals 0 on up to positive infinity, the graph goes up. So we say that the graph is increasing over that interval. I'll abbreviate increasing with INC. Over here, as we traverse the graph from left to right, the graph is going down. Clean up my artwork. The graph goes down until we get to 0. We say in this interval, the graph is decreasing. Now, let's pick a really simple variation of our function. I'll take this function and just multiply it by -1. That's the same as putting this negative sign in front of x squared. What difference will that make? Well, let's think about plotting some points. But let's not waste work. We've done all this work here. we can use it over here. When x is 0, we're going to get 0 again. When x is 1, well, x squared gives you 1, so we're just going to put a negative sign in front of that. And the same thing's going to happen for 2. 2 squared gives me 2, but I'm just going to put the negative sign in front of it. So I can look at this table here and say, oh, I'll just take all these y values and put negative signs in front of them. If you want to include 3 and negative 3, they're down here. So, what kind of difference does that make in the picture? I draw my coordinate system. There's 0, 0. Here's 1, negative 1. Here's negative 1, 1. Here's 2, negative 4. Negative 9 will be down there. Negative 3, negative 9 will be down there. And you see that same parabolic shape again. Let's connect the dots. Okay. A little messy, but you get the idea. It's exactly the same shape we saw here, but it has been flipped over the x-axis, flipped upside down. So we see this parabola opened upwards. This one opens downward. And it's that number multiplying the x squared. Here the number is -1. So we're observing that a is equal to -1 here, where a refers to the general form of the quadratic function. Here, a was the invisible 1, right? That's multiplying the x squared. So we see that when a was 1, it opened upwards. And that happens all the time. When a is positive, the parabola will open upwards. When a is negative, the parabola will open downwards. Okay. Let's stop at this point and have you graph your first parabolas. Go to page 170, problem 4 and problem 5. That will give you a little practice in doing this and getting used to the idea of drawing a parabola. Then we'll come back.